The learning goal for this lesson is to determine the end behavior of polynomial functions. Determine the end behavior of polynomial functions. Definition of end behavior is the behavior of the graph of f of x as x approaches positive infinity, there's the symbol for it, or negative infinity, again the symbols. Now what this basically means is what the graph looks like when it says x approaches positive infinity. That's on the right hand side, and when it says as x approaches negative infinity, that's what the graph looks like on the left hand side. So the end behavior is what the graph looks like on the right hand side of the graph and the left hand side of the graph. Here we see several examples of polynomial functions, and we're going to look at the end behavior of each one of them. So the first one is the constant function, and if we cover up the middle part here, we see some part of the graph on the left hand side and part of the graph on the right hand side. I'm going to go ahead and label that on the right hand side and the left hand side. And mathematically, the way we describe left and right hand side is on the left hand side, as x gets closer and closer to negative infinity. On the right hand side, as x approaches positive infinity. So let's see what happens on this graph of the constant function as x approaches the left hand side. The graph stays horizontal, stays constant. We'll say that f of x approaches c, that constant number. And on the right hand side, as x approaches positive infinity, moves farther and farther to the right, the function f of x stays at that constant value, f of x approaches c. For the linear function, the second one here, if we cover up the middle part of the graph, we'll see what happens to the left and to the right again. So let's go with the right hand side this time. First, as x approaches positive infinity, the graph continues to increase farther and farther up. So we say f of x approaches positive infinity. On the left hand side, as x approaches negative infinity, the graph goes farther and farther down. We say f of x approaches negative infinity. So for this quadratic function, if we cover up the middle, we see that the graph shoots downward and downward on both sides. So we can write on the right hand side, as x approaches positive infinity, f of x approaches negative infinity. On the left hand side here, we see as x approaches negative infinity, f of x approaches, it shoots downward, so it means it approaches negative infinity as well. Go ahead and pause the video and talk about the end behavior of these three polynomial functions. So now we have cubic functions graph, an example of a quartic function or degree 4 polynomials graph, and a quintic function or degree 5 polynomials graph. I want you to describe the end behavior of each of these three functions using that infinity notation with your neighbor. So let's see how you did. Here are the end behavior descriptions in the algebraic notation for each of the three graphs. So basically, when you see as x approaches negative infinity, here, here, and here, it's talking about the left-hand side of the graph. When it says f of x approaches negative infinity, it means the graph is shooting downward. And in this case, the graph is shooting downward. And when it says as x approaches positive infinity, here, here, and here, it's talking about the right-hand side of the graph. And when it says f of x approaches positive infinity, it means the graph is shooting upward. So on this graph, on both sides, the graph is shooting upwards. And on this graph, on the right-hand side, the graph is shooting upwards.